Welcome to lesson 5.1.1, and in this lesson we're going to be looking at the properties of the graphs of polynomial functions. Complete the following table.
Okay, so in this very short little lesson here, all we're going to do here is look at the expressions here and identify the different characteristics of the graphs of those functions there. Okay, now granted this isn't exactly written in function form. It really should be a y equals in the front here, but that's kind of not the point that we're trying to get at right now. So first of all, in this first column, we're going to identify the leading coefficients in each of these cases here. So what that requires us to do is first of all to find the term with the highest degree. Okay, and we're going to grab the coefficient. It's going to be -2. Here, the term with the highest degree is the first term here, x to the fourth, and the coefficient here is just going to be 1. So the n refers to the degree, okay? And the degree of the function is going to be the degree of the term with highest degree. So in this case here, this is going to be 3. This is a cubic. And this one here, the highest degree is the fourth. This is going to be a quartic. Okay, so end behavior. So this is really talking about what happens when you move far away from the origin. On either side, where is it? Okay, what quadrant is it in? Okay, because typically what happens with polynomial functions here is that it's got some sort of behavior. And usually, particularly for what we're going to see in high school, usually that behavior is going to occur somewhere in the neighborhood of the origin. But then as you move away from, when you move away from the origin, kind of wherever it ends up, that's whatever quadrant ends up, that's basically where it stays from that point forever. So because this is a negative odd function, this is going to start high and end low, this first one. So this is going to start in quadrant 2 and it's going to end in quadrant 4. It's going to basically move down, okay? Start up and then move down. We've got a positive fourth degree as our second equation here. Okay, a positive fourth degree. Now, anytime it's even degree, it's going to have a kind of, in essence, a bowl shape. There's going to be a little bit of wiggles in there, but it's going to have a bowl shape, either like this or like this. Because it's positive, this is going to open up. Okay, and so this is actually going to extend from quadrant 2, but it's going to end in quadrant 1. Going to come down, wiggle, and then go back up again. So now the possible number of x-intercepts. Now, when it comes to an odd degree function here, we know that it's got to have 1. Okay, odd functions are going to have at least one real root. And then because this is a cubic, it could have up to 3 x-intercepts. Okay, here, because it's an even function here, actually this one here could have no x-intercepts, but this one could go up as high as 4 x-intercepts when all's said and done. Okay? The y-intercept, okay, now the y-intercept actually in both of these cases, this is actually pretty easy here. Think about what happens when you find the y-intercept. You're going to make the x-coordinate equal to 0. And as soon as you do that, in this particular case here, all of these terms disappear. You're left with just the constant. So in this case here, that y-intercept is going to be -13. And as it turns out, and that's the point of this question, that's what the constant term is as well, -13. In this second one here, if you make x equal to 0, all of those disappear. We're left with +3. So that is my y-intercept, and once again, that is also, as it turns out, the constant term of this function. Okay? The last column we want to look at here is whether this thing has a max or a min or neither. Now, for those of you that might be taking calculus here, when we ask this question here, we are only talking about absolute max or absolute mins here. We're not talking about relative max or mins. Okay, so you got to bear that in mind here. So when it comes to an odd function starts, or in this particular case here, this one starts up at positive infinity, drops down to negative infinity. Okay, there are no points that are the absolute maximums or minimums here, so this actually is going to have neither. The second one here, though, is a positive even function. Okay, or sorry, it's got a positive, but it's a positive leading coefficient with an even degree. It's going to open up, which means at some point along the graph here, it's going to have a lowest y-coordinate. There's going to be a point there that's going to be the absolute minimum for this particular graph here. So this one's actually going to have a min. Okay? So that's what we're being asked to do here in this case here is we just want you to be able to look at these functions here with just a couple of examples. And I realize it's not a lot to go from here, but you really just want to go back through the notes and make sure you're comfortable with these rules and just really commit them rules to memory as we go through this, okay? So the whole point of this first little bit here is to give you an intuitive sense when you look at the graph, okay, when you look at the function, we want to give you an intuitive sense of what the graph is supposed to look like. And it just makes working with it that much easier.